So you're all in the back. I'm Donna, so I'm going to talk to you a little bit about what we do inside the classroom when we flip our classroom, right? So without giving you all the details about the flipping itself, but rather thinking about what we do with the students in the room itself. And so to motivate a little bit, which I don't think we really need to do in this particular setting, I just want to highlight some things that came out in the New York Times of all things. In 2015, there was an article in the Times titled, "Are College Lectures Unfair?" So I seem to not have a point of it, that's okay. So are college lectures unfair? And the article pointed out that college lectures don't serve every demographic of student. And so especially the low-income minority first-generation female students tend to do worse if they're in a lecture environment compared to something else. And then a couple of weeks later came a rebuttal that said, "Lecture me really," which was a woman saying that lecture is an incredibly important means by which information is transferred. And so the idea of doing away with lecture is incorrect. Students need to learn how to appreciate lecture. But the real kicker for me was what made this work is that lecture me really worked when the lecturer was good. And not every lecturer is good. And so every lecture you go to isn't great. And so what do we do in that case? And so really, we were already thinking about this, but there were three fundamental questions we started to ask. And one was, I'm a chemistry professor, so in STEM, where we have these very content-heavy courses, are we doing the best that we can for our students if all we're doing is lecturing them? And then on top of that, sort of interweaved with that, is what do we do with all the really great chemistry and science professors who aren't very good at lecturing in the classroom? So is there a way we can essentially normalize what's known as the instructor effect? Because even though we all have the content knowledge, we don't all relay that content knowledge in exactly the same way. And then thirdly, which is becoming more and more important, is as we move into the 21st century, how do we deliver all the content we need to deliver and simultaneously give our students the 21st century skills they need to be successful in this environment? And so these three questions really sort of drove this thinking of what we were doing when we started to flip our classroom. And Pam, who's sitting in the front, and Melissa have worked on this with me for many years, but what we started doing was thinking about stuff that was already well known. And so the first of this was the idea that active learning in the classroom increases student engagement. And we know that, and there are a huge number of examples that show that. And the second was the idea that if you can increase the structure in your classroom, students who are coming in underprepared can allow themselves to become better prepared over the course of the semester because they understand what it is that they're supposed to be doing. Because they haven't learned how to structure their learning through their high school experience. And so with these two things in mind, we started thinking about how we would flip our classroom. And if we were going to flip the classroom, the point was to be able to do more active learning. And so there are a huge number of active learning strategies that exist. These aren't all of them, these are just some. But we chose to focus really on two, which was thinking about peer instruction using iClickers and thinking about facilitated group work through workshops. And for the rest of today, I'm going to talk to you mostly about what it is that we've been doing with peer instruction using the iClicker. And so the biggest problem here is, what do we do in order to allow ourselves to do active learning in the classroom, right? And this is something that was addressed in the prior talk today, but if you need to have time in order to do active learning, what happens to the lecture content that you were delivering to the students beforehand? And so what people have historically done is simply cut course content, right? Because there isn't enough time to do everything. So we decide that there's a certain amount of content that isn't as important, and so I'm not going to teach it to you, you're going to do it as self-study because there's no other way to get through the material. And that wasn't incredibly effective because we were losing something. And so an alternative strategy came when we started thinking about moving the explication of content out of the classroom. And so one way to do this was to flip through a video backbone. And so Pam and I spent a number of years thinking about designing a video backbone to allow us to flip general chemistry. And so we flipped general chemistry in its entirety, Gen Chem 1 and Gen Chem 2. And when we did this, what was really powerful is that instead of just helping students think about what they were doing during the class, we realized we could also start structuring what the students were doing while they were at home. Because now we had control over both of those two environments, and we could really help them hone their skills on how to become better learners. And so in our flipped classroom, while the students are at home, they watch our videos, take notes, do online homework, and you can see my Mac to PC translation isn't working really well, and then they track their progress, right? But basically they're in an online environment where they are monitoring what they are doing. And then separate to that, they come to class, and in class, we do a whole lot of active learning with them, where we do modified peer instruction and group workshops. Interwoven into the backbone of all of this are three key principles, right? One is that there has to be a community of learners who feel safe learning within your classroom. Because if they don't feel safe, they're not going to be willing to try anything that they haven't done before. Second is you need to provide the structure to help the students grow as learners. And then third is this idea of distributed learning, which means that you spread the learning out over multiple modalities, so students are seeing the same thing multiple times. And so in our classroom, we give the students at the beginning of the semester a pacing guide, which basically tells them every single activity they have to do for the entire semester and when it's due. And so the different colors here indicate different types of things that they have to do. The dark blue squares are when they need to watch online videos and do online questions inside the video platform. The light blue is when they come to class to do workshop activities in small groups. The yellow is when they come to class for peer instruction. And then this salmon-y color on this end is when they have homework that they need to do at the end of the week. And so if you really think about what we're doing, we are essentially thinking about building a learning arc for our students where they start at home, we then build the learning throughout the week on campus, and then they close it out again at home. So they start every week by watching videos and answering a series of questions before they ever come to class. When they come to class, they then do workshops. They come to clicker class and do peer instruction. In clicker class, there's a second learning arc where what we do becomes progressively more difficult over the course of that quote-unquote lecture. And then they attend a host of office hours or tutoring hours to help them concretize that material. And then they close it out at home by doing their online homework. And really, a student is essentially closing the loop from what they started with to what they know at the end of the day. And so the way we make this happen is we need an online platform to work with. And so we have at this stage embedded our videos in two different commercially available platforms, Top Hat and Sapling Learning. Both of these integrate with Blackboard if one wants them to. And the big idea is that on this online platform, students are watching their videos, answering problems, tracking their progress in the course because they get real-time feedback about how they're doing. Simultaneously, we're posting all of the course documents so that they can look at those. And then they are doing something called a learning goal analysis, which I'm not going to talk about very much, but is basically something they do before they start, which is just asking them, do you already know anything about this content, yes or no, right? And so in class, clicker class, students come with a remote. And it's called an iClicker. This is just a picture, since my thing isn't working, of what an iClicker 2 looks like. They come in a variety of different types of iClickers, first generation through that one. They range in price from like $10 on Amazon if you're getting an old used one to this brand new one that's about $75. But the point is when the students come in, the entire class is then actively talking to one another and solving problems and then responding to those problems as individual students using the iClicker. There's a whole lot of different technologies you can use, but we chose to use the iClicker because that's the one that we preferenced, right? But any of them work. And this is obviously me in the classroom, and then here on the right is another classroom with a different instructor. And you can see that the instructor isn't front and center in any of these images, right? The students are working with one another. And I am, in both cases, talking to small groups of students about the problems that they are solving. And so what we're really trying to do here is have the students learn through problem solving, which means that as faculty, we need to learn to teach through problem solving, which isn't something we're all skilled at, because we know how to teach through lecturing, because that's how most of us learn. But we now need to learn to teach through problem solving. And so one way to think about doing that is to start looking at something called peer instruction. And so in the early 1990s, Eric Mazur, a physicist at Harvard, developed this idea of peer instruction, where he would go through a peer instruction cycle, where he would show students a targeted question and then force them to submit an individual response. And this was before there was any of the fancy technology there is now. Sometimes he had them submit responses just by using colored pieces of card that they showed the room so that everyone could see. He then showed the distribution of responses to everyone so that you could see what the class is voting for. You then have the opportunity to discuss with your peers because you don't all vote the same way. And he really did this to think about targeted conceptual questions in physics that students were struggling with, so he knew they wouldn't vote the same way. After that, students get to vote again. You look at the distribution again, and then you discuss the question, and then you start a new cycle. And so the idea here was the students start working with one another as you go through this peer instruction cycle. So we started to implement this in our classroom with our clicker questions, but we realized very quickly that if we got a class distribution where everybody did know the right answer, because we didn't have everything be complex conceptual questions, there's a lot of basic skills we also wanted. We didn't need to go through the whole cycle. We then went straight to discussing the question. But as things became more complicated, we realized that having the individual response didn't work very well for our students because they weren't willing to take the risk because they didn't know what the answer was. So where we've ended up is in a modified cycle where we essentially have the students go through multiple rounds of discussing with one another what they believe the right answer to the question should be. And so through this, we're essentially allowing the students to drive the learning in the classroom. Because if your students get it, you move through the content pretty quickly. But if your students are struggling, you have to slow yourself down and spend more time on that particular piece of content. And using the clickers, you get a really good sense of whether or not your students are actually getting it. Because what you think they know by verbal responses and what you see through the clicker responses is not the same, right? It was fascinating to me how different those two things were. But what this means is you have to design questions, right? So now how do you design clicker questions to allow you to do good peer instruction? In 2008, Klaus Wolf developed a clicker question taxonomy where he said clicker questions can be organized into one of three categories: I am, I do, and I will. So the I am category is where you as an instructor get to determine your students' attitudes or dispositions or their status, like I am here today, right? Or I am paying attention. It's simply a polling of the students. I do questions are where you're actually probing their learning, right? And you're allowing the students the opportunity to say to you as the instructor, I learn, I understand, I'm here, I apply. And then finally, I will, which is when students are willing to tell you that I will be there and I will be prepared. And so basically what he said is you write questions to poll your students, you write questions to test your students while they're learning, and then you write questions to make sure that they're going to review for when they come back next time. And this was great because no one had ever done anything like this before. But at the end of the day, this taxonomy wasn't linked to any instructional design. So you still don't have any idea of how to create your actual learning questions so that they're helping the students progress through the course of the lesson. And so what we realized is that doing this, developing the questions for the I do category, is actually quite complex. And so when we developed our flipped classroom, we wrote a new taxonomy for how to develop the clicker questions. And basically we came up with a 4-level taxonomy that started with foundational questions and ended with stretch questions. And I'll show you in a minute how these link very loosely to the modified Bloom's taxonomy. But the idea here was if you can write these questions accurately and you can understand the type of student distributions that are coming out of the questions, you can start to tailor the learning appropriately. And so when students answer the questions, we found we get one of four things. Either they get it all right, which means at least 70% of your students hold the right answer immediately, and you know everybody understands, and you just move on. Or the other extreme, where nobody gets it right, right? Less than 50% of the class gets it right, and you know they do not understand, and you need to spend a lot of time there. But then there are these two middle categories that are really interesting. Almost correct, which is, for us, we defined it to be about 60% of the students are getting it right, which is nice, but still 40% aren't there yet. So what do you do with that when you have 60% of your class with you, but 40% of your class not with you? And then even more interesting, what we find, what we call a split distribution, where you're having an even split of 50-50 between two responses. Split distributions are not random. These are questions you intentionally write to drive half of your class towards a misconception that you know they hold, so that you can address it as part of your lesson. And so these things become really important. And so if we go back to the taxonomy for a minute, this is an example of what a level 1 question might look like. It's a matching question, right? I'm going to use 4 math questions just because I think math is a universal language that everyone can speak. But this is basically, did you memorize the metric unit conversions and can you repeat them to me? So this is level 1. It's a single concept, single step, matches loosely to Bloom's Remember. And as you might predict, students are getting this right. On average, looking at students at Hunter and at Lehman, 2 of the CUNY colleges, over 5 years, we're finding that students get these types of questions 81.6% correct. So it means about 82% of the students are getting these questions right. While that's great, it's actually kind of scary because this is just a matching remember, and it's only 82% of them getting it right? So they're not all there yet. But that's okay, because remember, this is a flipped classroom, and you haven't actually taught them the content yet. They've been doing it on their own up to this stage. So the goal is not that they know it when they come in, it's that they know it by the time they've left at the end of the day. The level 2 questions are still single concept, but now you're starting to introduce multiple steps towards being able to solve these problems. And so something where you might ask them now to actually use the unit conversion to do a conversion, instead of just what the conversion is, or something where you might ask them to not only bring knowledge in, but also apply it to a problem. In this case, we're finding that about 73% of the students are getting the questions right. And if you look at the histogram all the way on the left, here we have got a split distribution. And that's intentional, because this second question, how many hectares are there in 2.2 kilometers squared? I know with certainty half of my class is going to square the unit and forget to square the 2.2, right? So I know I'm going to get the split distribution, and so I drive my class towards that error so that I can deal with it in class and we can talk about it. And it's not just something that's on the wayside, but it's brought front and center. And this happens even with a level 2 question, right, which is a very basic, easy question students should be able to solve. Level 3 starts to take it a little bit more complex, where now you're not just looking at multiple steps, but also multiple concepts within the problem. And I would say on our exams, most of our 60% of our exam is sort of level 2, so you can pass. But then if you want to get an A in the class, you have to be able to answer these level 3 questions. Otherwise, you haven't demonstrated the depth of knowledge that you need. And so here, it might be something like, what's the correct calculation to determine how many ounces in grams? So we would give them the conversion factor for ounce to grams, but they would need to know the metric conversion factors. They would need to be able to do the math, but then they would also need to be able to accurately match what they wrote in their notebook to the options that we are giving them, because it isn't just a value at the end, it's the actual mathematical setup. And so now we're taking them to Bloom's analyze and evaluate, because can you analyze the question and then evaluate what you got and compare it to what's in front of you? And in this case, as would be expected, the rates are going down. 65% of the students are getting this right. And now again, you're starting to see split distributions in the center, or even totally mixed distributions, where you're realizing that most of the kids don't know how to do this. In this particular problem, we start playing with 10 to the third and 1,000 and 10 to the minus 3, and we realize our students are struggling with basic numeracy, right? So we build that into this kind of question to deal with it. And then finally would be level 4 questions, which is a real stretch. And so here this would map onto Bloom's evaluate and then create. And so this is a chemistry course in which I've never talked to the students about how to calculate an area, but in order to solve this problem, they have to figure out the area of the lawn. And so that would be the create part of this. They've got math skills because they need calculus or pre-calculus to get into the course, so they should have done this somewhere else. But these are really the questions that are going to push your students to getting 100% on the exam, not just an A, right? And so here we're finding that less than 50% of the students are getting it right, which is expected, right? Because these are not questions that you expect the whole class to be able to do to succeed in the course. And so then we come back to this learning arc, right? The students start at home and end at home, but what goes on in Clicker class is building a second small learning arc where you pick a topic that you know is going to be difficult for your students and you use the Clicker taxonomy to design a series of questions that become progressively more difficult in class time. And then you allow the students to grapple with those concepts as they're learning instead of just having you solve all the problems for them. And so the last things I want to leave you with are just, does any of this work? So we've published extensively on the success of the flipped classroom, so I'm not going to talk to you about that, but just the students' perceptions. 91% of our students enjoy Clicker class more than workshop. And 98% of our students find Clicker class to be helpful to their learning. And then if we poll them about what they want in a subsequent semester, do they want Clicker class and workshop, or would they prefer just Clicker or just workshop? It's kind of fascinating because they're all choosing Clicker class over workshop. And there are multiple reasons this might be. We believed workshop was really important because students got to work in small groups and grapple with ideas, but we're realizing that they do that in Clicker class. So in Clicker class, they are actually sitting in small groups and grappling with ideas anyway. But now they're doing it in a larger setting where they feel a little bit more safe because they're not handing in one group grade, they're handing in individual responses. So I might not agree with all the members in my group, but I do get to discuss it with them, and then I make an individual response. So over time, we have actually done away with workshop. And if you look at our new pacing guide, we've got 2 2-hour Clicker sessions every week that students come to where we've slowed things down a little bit because we've got time and allowed them to really grapple with these ideas during class time. And then finally, these are just some of the random student quotes that have come in on teacher evaluations, thinking about in a free response, right? So students comment that Clicker sessions made learning more exciting. Class time went by really quickly. The class is fully engaged. I love Clicker class. Class makes chemistry fun. I love it when we do Clicker questions. So they clearly are vested in this kind of learning. And so I think with that, I will thank you for your time. And if you have any questions, please feel free to ask them. Yeah.
You said the student satisfaction was really high with class. Did you compare grade outcomes between workshop and Clicker class, Clicker classes?
So the workshop and Clicker have always gone together, and it's always been part of one grade. And so what we have focused really on is looking at grade outcomes of a flipped classroom versus a traditional classroom, or a flipped classroom versus an active classroom. But we have not yet disaggregated the impact of workshop and Clickers on the student outcomes. Anything else?
Yes, good questions.
Okay.
Thank you so much.
You're welcome. Thank you.